There's a battle going on. The moth's best-known predator scores again. It's a one-sided fight, but not for everyone. Some moths have a secret weapon, and its evolution is revealing a new story about when butterflies left the dark side to become creatures of the light.
Hey there, quick interruption. Just wanted to let you know how happy we are with the high amount of views on our YouTube channel, but so many of you are not subscribed yet. So please, if you like our content, consider subscribing. It really helps a lot. Thank you.
A group of researchers are on a quest to solve an enduring scientific mystery. Why did moths evolve into butterflies? They're in Gorongosa National Park, a roughly 4,000 square kilometer expanse of wilderness in the southern African country of Mozambique. It's a biodiversity hotspot. Many charismatic megafauna live here, but it's the little ones they're looking for. So far, scientists know that at least 236 species of butterfly and moth live in the park. Akito Kawahara of the Florida Museum of Natural History is leading the expedition. He wants to find out how butterflies became what they are now. Scientists already know that butterflies evolved from moths. But what environmental factors were at play for this extraordinary change to take place? Akito is already considering one theory, that they flew to the light to escape nocturnal dangers. Knowing about moth evolution is key to understanding what happened. The first moths came onto the scene between 250 and 300 million years ago in the Carboniferous period. It was swampy. The moths were tiny, and they survived by sucking up sweet excretions from ferns. They became an incredibly diverse group. Today, there are around 160,000 different species of moth compared to 17,500 species of butterfly. They were the first of the Lepidoptera family to play an important role in pollination. Moths became indispensable to night-blooming flowers. They evolved together. But not all moths work the night shift. The hummingbird hawk moth is a daytime pollinator. It acts, looks, and sounds just like a hummingbird. It evolved the same traits to thrive in similar environments. The hummingbird hawk moth has a proboscis almost as long as its body, designed to access hard-to-reach nectar deep inside flowers, just like a hummingbird's beak. The disguise comes with another advantage. Birds are major predators. Mimicking the enemy is a great way to survive the day. In the night skies of Gorongosa National Park, there's another ingenious moth survival strategy at work. Bat acoustics expert Jesse Barber from Boise State University joins Akito and his team to record a battle between bats and moths. The scientists set up sensitive equipment to detect all the night sounds imperceptible to human ears. Bats aren't the only ones sending signals here. Bat versus moth doesn't seem like a fair battle. Bats have an advanced weapons system which they developed around 50 million years ago, echolocation. This sinister gaping mouth emits high-pitched sounds from the larynx that bounce off objects in the environment. The returning sound waves accurately locate prey. At speeds of around 150 kilometers per hour, the bat zooms in to scoop up the moth in its wing membrane. The microphones pick up other strange sounds. They're coming from some of the moths, and they're pitched at the same high frequency that the bats are using. It seems the moths and bats are involved in an acoustic arms race. The scientists find further proof by catching moths and recording their reaction to bat echolocation sounds. The moths project their own high-frequency sounds. It's like a screaming match between species. They produce ultrasonic clicking sounds at a rate of 4,500 times per second. In the process, the moths blanket the surrounding environment and block the bat's sonar. They become undetectable. This is one of a number of strategies moths evolved to evade bats. Akito Kawahara wondered if some moths decided on a more extreme shift in behavior. By trading night for day, they could leave the bats behind forever and become beauty queens in the process. According to the known fossil record, the appearance of bat sonar coincided with the arrival of butterflies. It looked as if bats drove moths to become butterflies, but the story turned out to be far more complex. A few years after he came up with his hypothesis, new fossil imaging and genome analysis techniques allowed Kawahara to dig deeper into the question of butterfly evolution. Akito and his team collected DNA from all the major families of butterflies and moths to construct a Lepidoptera family tree. For the first time, it revealed the timing of major milestones in moth and butterfly evolution. The team traced the ancestor of butterflies back to around 98 million years ago, almost twice as long ago as previously thought. Bats weren't even present when the ancestral moth became a butterfly. Akito had disproved his own theory, which brought the scientists back to the question, why did butterflies evolve? Akito Kawahara now thinks the origin of butterflies is tied to plants and bees. Scientists believe that pollinating bees evolved shortly before butterflies did, between 100 and 120 million years ago, at the same time as flowering plants began to proliferate. Bees and flowers most likely co-evolved. Each had what the other needed. The flowers needed bees to pollinate them. They made themselves continually attractive by expanding their range of colors, shapes, and sizes. Bees also diversified their looks and behaviors to get to the pollen they needed. Some night-living moths saw an opportunity and came to exploit the abundant new source of pollen. They evolved their own colors to suit. So, bats didn't drive butterfly evolution. For now, it looks like bees were the major players, and as new methods of data gathering are discovered, other theories may emerge. That's how science works. Their beauty may attract our attention, but without moths, butterflies wouldn't exist. They're essentially just day-flying moths. And after dark, their unassuming relatives jam the radars of their enemies in the night skies. Want to see more amazing insects? Then please consider to subscribe and check out our Best of Insects playlist, where you can meet the busy leafcutter ants, and some others that like insects too.